Speech volume up. Can you hear me now? The lamest joke of all time. Lamest ad of all time, too. All right, so it is Tuesday. It is February. That means we are in week 3. There's only 14 weeks in this quarter, so we are in the midst of some very important material, which is all going to appear on your first midterm. Midterm, an exam, where I ask you to solve difficult problems relating to this material. This stuff may seem straightforward, but trust me, it's not, all right? You're probably all going, it's not straightforward, Max, we know that, so let's keep on going. So what did we do last time? Last time, we related preferences, which we argue are transitive, complete, and non-satiable, and we said we could translate our preferences into something called a utility function. A utility function is just a mathematical representation of our preferences, and the nice thing about utility functions, which are these 3D mountains of happiness, could be mapped into our indifference curves, where our indifference curves are essentially just slices of the utility function. Just if I look at different levels of the utility function, and I look straight down in my space of Reese's and Hershey's. I'm going rapidly here because I've said it 4 times already. The important part here is that there's 2 different measures of utility that I'm interested in. One is the overall level of happiness, which doesn't really mean anything, right? It's just an ordinal ranking of how happy one bundle makes me versus another. But then there's this concept of marginal utility, which means how much additional utility do I get out of consuming 1 more unit of whatever good I'm interested in, holding everything else constant, all right? I'm holding consumption of all other goods constant. I'm just giving 1 more unit of one of the goods, and I'm checking how much my utility goes up by. So it's a change in utility. What we then did is we said, well, we talked about this concept of a marginal rate of substitution, the rate at which I'm willing to trade in Reese's for more Hershey's, and we showed with the first proof ever in this class that that marginal rate of substitution is exactly equal to the ratio of marginal utilities, meaning the rate at which I'm willing to substitute away from Reese's towards more Hershey's is exactly equal to the ratio of the marginal utility from the loss of Reese's relative to the gain in marginal utility from Hershey's. All right? That's pretty neat. So what that tied up is our tastes, preferences, the things we like, and how we like different bundles relative to each other. So that was just preferences, just tastes. No scarcity yet. No issue of we don't have any money. I'm broke, Max, right? There were no prices. There was no income. That was next. We're talking about the budget constraint now. The budget constraint is our measure of scarcity. 3 things determine the budget constraints in our 2 good world: the income, right, the level of nominal income, and the price of good A, and the price of good B. Once I know how much money I have to spend, plus what the cost per unit of these 2 goods is, I can fully determine scarcity in the picture that we showed last time, which was this nice triangle, which we call the opportunity set, and the frontier of that triangle was called the budget constraint. The slope of the budget constraint, which is the rate at which the market or the vendor will let you convert Reese's into more Hershey's, we call it the marginal rate of transformation. It's an exchange rate, right? The easiest way to think about this when you travel is at what rate does one country let you convert its currency into US dollars and the other way around? It's the exchange rate, right? So the marginal rate of transformation, instead of an exchange rate from dollars into euros, is actually an exchange rate from Reese's into Hershey's, right? But same thing, right? One is currencies, the other one is yummy chocolate with carbohydrates and high fructose corn syrup in it, but idea is exactly the same. What we then showed is that the marginal rate of transformation, which is the slope of the budget constraint, is simply, by doing some simple math, the ratio of the prices of the 2 goods we're looking at, all right? So what that got me is that at the optimal point of consumption, and that's where we ended up last time, and I'm sorry that this is sort of a lengthy review, but there's a lot happening here already, and we're about to hit the highway with our new Nissan, whatever, GTR. Oh no, don't let me down. You know, Microsoft, you put the Space Needle on there. You know this is your fault. All right, let's try this again. There's a lot going on here, right? So last time we ended up with the optimal consumption bundle where we, given our budget constraint, which is nailed down by income and the relative prices, we tried to get on the highest indifference curve we possibly could, and at that optimal consumption bundle, we showed that that indifference curve was exactly tangent to the budget constraint. So let me draw this for you one more time, and I have now figured out what really, I guess as the kids say, tripped me up, or at least they used to say in the 70s, I'm a little bit behind the times, but the problem last time was that my giant hands were wiggling around the slide while I was drawing, so now I've disabled the touch function of this pad, so hopefully the drawing will go a little bit better. Of course, now I don't know how to get to the next page. Here we go. So the picture we looked at last time was the following. Let's just go through it one more time. So think about, this is not such a happy experience. So think about if your income is $14, the price of Reese's is $2, and the price of Hershey's is also $2. Very imaginative, Max. Okay? That means if I spend all my money on Reese's, which in Max's world, Reese's are just awesome, so they're on the y-axis. Hershey's, also awesome, but not quite as awesome. They're on the x-axis. So Reese's y-axis, Hershey's on the x-axis. If I want to draw my budget constraint, it's always a straight line. So I just need 2 points, right? In order to draw a straight line, I just need 2 points on the line, and I'm done. So if I spend all my income on Reese's, how many Reese's can I buy? 7, right? You got $14, it's $2 a bag of Reese's, so you can buy 7 bags. Right? So the first point on your budget constraint is this point right here. If I spend all my money on Hershey's, how many Hershey's can I buy? Same amount, 7, right? They're the same price. So now I've got 2 points on my budget constraint. I can take my ruler, which of course I've left on my desk, so I'm taking this box. No, good job, Max. Let's try that one again. We can do this. We're all learning together how bad Max is at drawing stuff. Okay, let's try this again. 1, and so here's my budget constraint. That actually looks pretty good. Okay, that's my budget constraint. So the opportunity set is this whole triangle right here. The budget constraint is the frontier of my opportunity set. So this triangle, whose corners are 0, 0, 7, 0, and 0, 7, that's my entire opportunity set. Those are all the bundles, all the combinations of Hershey's and Reese's I can afford with my $14 of income, and given that prices are $2 each. The question now is, which bundle do I want to consume? Now, I'm going to try and get on the highest indifference curve I can get on using Max's preferences. Your preferences may look very different, but I only know mine. I don't know you guys very well yet. At the end of the semester, I'll recognize you by your indifference curves. Okay, this is what my indifference curve over these 2 goods looks like. There's no way I can get on a higher indifference curve and still be tangent, share a point with the budget constraint. If I were on any lower indifference curve, I could always get on a higher one, namely I1, and be better off and still be able to afford the bundle. So I1, which is meant to be exactly tangent to the budget constraint right here, this bundle right here is a bundle I can just afford. I'm spending all of my income, and it gets me on the highest indifference curve I can possibly get on. Now, when I started this class 2.5 weeks ago, or whenever it was, in the far distant past, I said, economics is just a social science, right? different social science disciplines are good at different things. So economics, I argued, is really good at explaining how people make choices in the face of scarcity. Now, this is our most basic model that shows how individuals make choices in the face of scarcity. We argued that individuals, well, we didn't argue, I argued, that individuals try and make themselves as well off as they can in the face of scarcity. Or in the language that I understand, that nobody in my house understands, but you guys do, which is why I like you guys so much, means I'm trying to get on the highest indifference curve I can, given that I still consume a bundle on the budget constraint. All right? For those of you who are a little bit confused, Max, this indifference curve doesn't seem to quite touch the budget constraint. It's a little bit off. That's just because I can't draw on this tablet, right? What I mean here is that this indifference curve comes in forever smooth right here, touches exactly 1 point on the budget constraint, and then disappears again, right? Which is why I use the big dot right here. So how do we show how many units of Reese's I consume? I just go across horizontally here. This tells me, oh, man. I hate Windows. This is why I went to Mac in the first place, but this thing really draws so much better. So it's okay. The next couple of slides don't have any pictures. So while this thing updates for the next 14 hours, I'm going to use the Blackboard and we'll be okay. I hope I don't get sued by Microsoft for saying on iTunes U that I hate Windows. Bill Gates, I love you. You're great. I have problems with your automatic updating strategy. You're not getting me on my highest indifference curve. So just quickly, to go back using the technology that works, that was the budget constraint. I just drew you 7, 7. Here's my indifference curve, I1. What I meant to say is that the optimal number of Reese's you can just read off by going over on the y-axis, and the optimal number of Hershey's you can read off by going down on the x-axis. So R star, H star, is the optimal consumption bundle that I want to consume, given that this is the budget constraint I face, and the indifference curve. This is really funny. Did you just see that in spelling update 5 of 4? Wow. I'll bring you guys a big bag of chocolate next time and send Microsoft the bill. Okay, so this is pretty cool, right? So this is the tangency property. That means if I have an interior solution where I consume some of both goods, this tangency property holds. It doesn't always hold, all right? There are moments when it doesn't hold, and we will visit those in a second. Those are called corner solution. But what I want to get into is for a second more is look a little bit at this notion where we said the rate at which you're willing to substitute between Reese's and Hershey's at the optimal consumption bundle is equal to the rate at which the market lets you transform Reese's into Hershey's. The marginal rate of substitution is equal to the marginal rate of transformation. Now that's exciting, all right, to me. To you, that's maybe not that exciting. So let me rewrite this thing for a second. Marginal rate of substitution is, as we proved last time, equal to the marginal utility of Hershey's relative to the marginal utility from Reese's. That's equal to the marginal rate of transformation, and the marginal rate of transformation, we said, is equal to the ratio of prices. We showed this maybe 2 lectures ago. This we definitely showed last time. So if the indifference curve is tangent to the budget constraint, that means the marginal rate of substitution is equal to the marginal rate of transformation. That also means that the marginal rate of substitution, which is just the ratio of marginal utilities, is equal to the marginal rate of transformation, which is just the ratio of prices. Right? I'm just setting things equal, but changing the notation here a little bit. MRS, written as marginal utilities, MRT, written as price ratio. Now I'm going to do some incredibly difficult math, okay? It's going to be really hard. I'm going to divide both sides by pH, that brings pH down here, and I'm going to multiply both sides by MUR, that brings MUR over here. Okay? Really difficult math. So what does that mean? At the optimal interior consumption bundle, right, this point where the indifference curve is exactly tangent to the budget constraint, the marginal rate of substitution is equal to the marginal rate of transformation. The ratio of marginal utilities is equal to the price ratio. Nobody understands that. But what I'm saying now is that the marginal utility divided by the price of the marginal utility from Hershey's divided by the price of Hershey's is exactly equal to the marginal utility divided by the price of Reese's. So now you tell me and you say, hey Max, that seems pretty exciting, and I'm glad that makes you happy. But it doesn't mean anything to me. So let me try and convince you that this is a really neat expression. All right? Why is this expression neat? Anybody here who likes Porsches and who likes Reese's peanut butter cups? Porsche German vehicle, really fast. Any volunteers? All right. So if I offered you the choice between one Porsche 911 4S with the sound package, very important, and one Reese's peanut butter cup, which one of the two do you think gives you a higher marginal utility? The Porsche, right? I mean, quite clear. The Porsche, if you look at the price tag of that car, is 140, 50, it's north of $100,000. So you could buy 10 of my cars. What's the price of one Reese's peanut butter cup? 20 cents. All right. Right. So that's an excellent question. I like it. All right, a big one. So probably like 50 cents? Yeah, something like that. A pack of 2 with taxes $1 roughly. So the point here, if I told you that at equilibrium at the optimal consumption bundle, the marginal utility from one Porsche, meaning the additional happiness you get from one Porsche, has to be the same as the marginal utility from one Reese's peanut butter cup, you're going to look at me and say, I'm walking over to political science because economics is a crazy social science. That just can't be right. Right? So what do we do here? So if Hershey's are Porsches for a second, what are we normalizing the additional happiness we get from one unit of Porsche by? It's price. Right? So we're dividing it by price. So what this now says is the additional happiness or utility I get from $1 more spent on Porsches has to be exactly equal to the additional utility I get from spending $1 more on Reese's. So what this means is if you have 2 goods and you're looking at that marginal dollar, right? I walked in without cash and without chocolate today, so no demonstrations. But the point here is if I have my last dollar and I look at it, what I'm arguing is at the optimal consumption bundle, I'm exactly indifferent whether I should spend that last dollar on one good versus the other one, right? So shifting that dollar between A or B, I'm really indifferent between the two. Why does this have to be right? Well, consider the opposite. What if you were much more excited to spend $1 on Reese's than $1 on Hershey's? Would you shift away from your current consumption bundle? Yeah, you'd shift towards Reese's because that additional dollar towards Reese's gives you much more additional utility than shifting towards Hershey's. So you have no incentive to stay still, right? It can't be an equilibrium. It can't be the optimal. The only time it can be an optimum is if you're standing there, and maybe $1 is a bad example. Maybe we should think of the last penny you have. If with that last penny, you're indifferent between spending it on Reese's or Hershey's because you like the additional unit exactly the same at the bundle you're at, you have no incentive to go towards Reese's or towards Hershey's. So the optimal consumption bundle, right? This point of tangency between the indifference curve and the budget constraint can be phrased in 3 different ways. Way 1, marginal rate of substitution is equal to marginal rate of transformation. Way 2, the ratio of marginal utilities is equal to the price ratios. This is the least intuitive one. Way 3, and that's my preferred way, is to simply say, at the optimum, I'm indifferent between spending $1 more on Hershey's or $1 more on Reese's. So spending that last dollar on Hershey's or Reese's gives me the same utility, additional utility, so I have no incentive to move away from my current consumption bundle. All right? So this is a little bit tricky to get, and you will think about it. Ooh, now you're going to see my password. That's also my PIN number. Hold on. That would be bad. Some hacker somewhere just, scraped that off my screen interaction. I am now poor. Dear hacker, I have bad news for you. I was poor to begin with. There's really nothing to get here. All right. Wow. This is exciting. We're back where we were. Okay. So just to be clear, this is what's on the blackboard here, beautifully in typeset. At the optimal bundle, these 3 ways are equivalent. Saying these 3 things on the exam are all correct, but it just shows you what's going on at that optimum. Okay? So, Max, I have a question for you. What's it like to be an economist? We'll talk about that one later. But do we always consume positive quantities of all goods? Question in the back. Yeah, so this is, okay. That's an excellent idea. I like the way you think already. What's your name? All right, nice to meet you. Good question. So what you're telling me is, well, Max, that's kind of cute, but I don't really care about getting, $1's worth of portion. Okay. So what I want you to think of is in terms of use of time of a certain good. Okay. Do you think in your lifetime you will own a Lamborghini Murcielago ever? Probably not, right? Most of us probably won't, and all of us shouldn't, because it gets 3 miles to the gallon, and climate change is a real thing, I think. So can you, however, drive a Lamborghini Murcielago if you wanted to? In fact, you can. Somebody gave it to me for Christmas. $99, 3 laps in a Lamborghini as fast as you can go, at your own risk. Don't do it. It's terrifying. It's awesome. That's terrifying. Okay. So while you don't have, the $290,000 or whatever it costs to get a Lamborghini, you can buy a fraction of the use of the Lamborghini for smaller amounts of money, right? If you may not have the money to own a car, but Berkeley, I think, gives you free or highly subsidized access to Zipcar or one of those. So while you may not have money for a car, you can spend $6 to go to the grocery store by using a share of the car over time, right? So you could think of the price of a car as the price per minute use of that car if there's a market where people will allow you to buy shares of goods by, sort of leasing them or buying timeshares. So excellent question, and that's the way we should be thinking about it. Okay, corner solutions. So Max, do we always consume positive quantities of goods? Meaning, do we consume some of everything, right? My universe now contains 2 goods, and it says I consume both Hershey's and Reese's. Are there certain goods that you don't consume some of? Who here doesn't drink Dom Perignon? Most of us, right? Why? Because even at Costco, it costs $140 a bottle, right? And it's champagne, and it's over after like 0.7 liters of bubbliness. It's expensive, right? For $140, I can buy enough bottled water for 2 years, essentially. So I don't consume any very expensive champagne. So does this model, Max, allow for settings where we don't consume some of certain goods? Well, the answer is yes, it does, and we call that a corner solution. So the corner solution, as opposed to the interior solution that we just saw, is a setting where the outcome, the ultimate optimal consumption bundle, is one where you only consume some of one good and none of the other. So at the optimal consumption bundle, Max only consumes Reese's, for example, no Hershey's. And what I'm going to argue is that the first setting where we're going to see this is one where goods are perfect substitutes, right? It's perfectly intuitive, but I'll walk you through the graph for it. So the key to this particular piece of insight, and I've asked this on exams quite a bit, is the ultimate equilibrium, or the point where we are at the optimum, where we're on the highest indifference curve we can get on, and still have a point on the budget constraint. At that point, for these corner solutions, often the marginal rate of substitution is not equal to the marginal rate of transformation. All right? So at corner solutions, that doesn't have to be true, and I'll show you why in a second. But at interior solutions, in most settings, except for one that I can think of, that's true. All right? And we'll see that one in a problem set. Okay, so let's walk through corner solutions for a second. The first example I want to think of is the example of perfect substitutes. So Max, I don't have a very distinct, how do you say, a fancy palate, right? I'm not fancy. I like water. Dasani, Arrowhead, perfect substitutes. I've been to a conference where water was free, and a person essentially said, I don't drink this kind of bottled water. Do you have another one? Come on. Yeah. So to me, bottled water is bottled water. Dasani and Arrowhead are perfect substitutes. Let's assume we've got here, let me make sure I get my units straight. Dasani on the y-axis, Arrowhead on the x-axis, and they're both in 16-ounce bottles, right? Perfect substitutes to me. I have $8 of income. The price of Dasani and the price of Arrowhead is $1 each. Okay, so the first point on my budget constraint is 8 bottles of Dasani. The second point on my budget constraint is 8 bottles of Arrowhead. And then I can draw a straight line through these 2 points here. Good enough.